Thank you for your patience. So earlier this afternoon, Tim McNamara gave us a talk about lesser-known data structures. So he's back again with his talk on practical profiling. Please welcome him.
Thanks everyone for having the energy to stick around, and I'm hoping that we're going to have sort of an entertaining end to the rest of the day. Has anyone put a talk proposal in for something that they really wanted to spend a couple of months researching because they kind of really wanted to figure out how to get it working? Anyone else? Point at myself. Okay, so this is kind of not really a tutorial. There are plenty of research, plenty of other talks even about profiling. This is kind of my attempt at trying to figure out how to use the tools that are available and are documented in the ecosystem into my own personal workflow. To get going, there's profiling, which kind of gives us evidence, and then optimization, which we can and they are sort of interrelated, but we're mainly talking about instrumenting our code to gather evidence and not really talking so much about how to use that data to optimize. There is a little bit. I just wanted to say one very, very quick thing. If you're reading off disk, sometimes it can be really helpful if you use TIMPFS to just throw everything in RAM and then read off that. So that's kind of the only optimization thing that I just wanted to plug. But yeah. So I'd love to think that once upon a time, development looks a little bit like you've got this brainwave, you move around to writing code, you then run code, and you kind of have this lovely recircle that's really productive. But now you're being told, you've got your unit tests that you've got to write first, and you run those tests before you run the code, and kind of iterate through again and again and again. But if you're working within a team environment, you also need to kind of coordinate your work or what you're doing with them. You've got your Ansible playbook because you need to deploy Elastic infrastructure, your Docker file, so that everything is containerized and highly secure. And you might also want to configure your own SDN and maybe your own CDN if you're delivering static files. Then you run your tests, right? Deploy your infrastructure, and then you can finally run your code, and then you repeat. But we haven't actually introduced branching into this, but I'll kind of stop there. The other question that's probably quite important for people when they're actually trying to get this on a day-to-day basis is, where do we spend our time and energy? There's a bunch of things that we can instrument, and if we're using multiple processes, distributed programming, or multi-threading, it gets even harder. I've been reading quite a few blog posts on tutorials and so forth around the tools that are available, and the sentiment out there isn't positive. And the other thing is that from the user's perspective, the distinction between kind of the system Python that you sort of apt-get install is a little bit different than the Python standard library sometimes. So this Ubuntu user has had a little bit of difficulty figuring that distinction out too. I really hope that someone isn't the developer of this code sheet thing. So. But this is some public code, and what you've got here is probably an iterative cycle of profiling specific bits of technology, changing function names, changing parameters within each of the variables, kind of doing it, and then wanting it to stop in the right place so you can actually check on things. And just so that I had a brief look, this code sheet thing creates sheet music or creates PDFs of sheet music from ASCII, for as far as I can tell. And so what is the right workflow to get everything working together? Because clearly, as I have found it, it's been really quite tough. So we have all of these issues. It's unclear. It's another thing that we need to bolt onto our development cycle. But really, there are some useful reasons to actually consider profiling as something kind of good to do. We've got this intuition that faster code is better code, and cooler, more power-efficient servers means that we're going to be able to scale up as our system and our service grows, and we're also going to be reducing our impact environmentally. So this is just a very small survey about some of the tools that are available to you. Some of them you undoubtedly would have used in various ways before. In particular, we're going to be focusing on this thing, Memory Profiler, the CPython C profile tools, which comes in this line profiler thing as well, just because they seem quite practical and relatively widely adopted. Hey, can I just get, is there anyone for which these tools are completely new? OK, that's just fine, right? So Memory Profiler. I wanted to start here because it's the best example, I think, of quite a good user experience. We've kind of got our function. This is ripped out of the documentation. You know, some sort of computationally expensive, memory expensive operation. We're expanding these two lists quite big. It's pretty bad grammar there, but we then execute. So that's IPython. And we get this output for each line in our file. What does this do before and after it's executed in terms of memory utilization? So I think in terms of being a tool that's relatively easy to use, this is pretty good, right? You add a decorator to a function that you want to have profiled because you have some suspicion that that's relatively expensive, and then you kind of get a really, really handy output. So as kind of was touched upon in one of these quotes, the standard library actually has 3 profilers. It has 2 implementations of a deterministic profiler. One's implemented in C and one's implemented in Python. That's easier for you as a developer to extend. And this is sort of the hotshot thing, which is which samples. It's non-deterministic, but it's easier to sort of turn on and off. Which I'm focusing on the C profile because it is very well documented, robust, and it's been around for a while. So to use it, this is again as a shell command. This is how it's often sort of seen. Python -module C profile provide an output result. Completely arbitrary. It's just a file name, so we're just going to call it result.profile. And our application is just called app.py. And to interpret it, so this result.prof thing will be a binary file that is completely opaque to us. Pstats is kind of comes to our rescue. It's actually in the same document file if you go hunt for C profile in the documentation. So we import this pstats thing, create a stats object. We strip some. That's the function directory names, so that things are slightly more readable. We could say sort by cumulative time and print out the top 20 functions that took time. We can also do this all interactively via calling pstats module from the command line as well. So here was my attempt at creating something computationally expensive to kind of talk about. Ignore everything, really. What we're really trying to consider is the difference between a comprehension and a for loop, because I've heard often that comprehensions are much, much faster than for loops, and I kind of thought might be something worthwhile testing out. So, and the other thing I've also done is included my or sort of a relatively rubbish implementation of some versus the built-in. So if we just run python -m C profile and work.py, which is the name of the file that we just created, this is the output that we get. The ordering is by this column. So relatively, so we need to kind of adapt that. To change this, we provide the S parameter, which is kind of more useful to us. We can see that the use for loop indeed took much more than the use comprehensions function. In fact, total time there was sort of 0.19 of a second versus 0.09, so roughly double for our particular case. Line Profiler does exactly the same in terms of output for you that the memory profile example that we've already seen. So you actually get, this is your line, this is the amount of time that Python spent in there, and so forth. I just thought, since we've already looked at memory profiler, we'll just kind of skip that one. But I'm very, very interested in considering what a reproducible, say, profiling workflow would actually look like. How do we fit it into that really long go-to loop that we started with? This is where, happily doing hand-wavy stuff, I've got this intuition that hooking into the integration test is probably the best place. If we run our profiler over the entire application, one, we're probably calling, we're probably calling too much code in the sense that most of our code is going to be good enough, and the other thing about integration tests is if we stay slightly higher than a unit test, we don't encounter the problem that if specific functionality changes or we refactor the code, hopefully our profiling results will be able to be measured and monitored over time more easily. So this is just sort of the intuition that I have. I really feel that for this to be useful or a useful tool, you need to be able to track your results over time. And ideally sort of bolt it on to the continuous integration or continuous deployment process. Because if we've already got, like, I don't know, pick your continuous integration tool running, and it's already building your code at every commit, it may as well run some, and it's already doing all of your unit tests, it may as well also do a couple of profiling runs as well. But this is like, but I did spend sort of 6 weeks looking at how people actually use these tools. And I did that through this OLO search functionality. One thing that I found really interesting is that if you sort of search for import, and have the Python filter on, you get back 1.6 million results. So I think that's and there's lots of duplication in there because if there's multiple files and so forth. But for the import profile was sort of not as useful, actually, as it happens. But if you hunt for the call, profile.run, you have far fewer results than I would have anticipated. And possibly that, I'm just thinking about it now, is because many of these tools are designed to be run from the command line. But when people do try to create an automated and repeatable process for themselves, there's actually very few people using it. So I tried to find some great examples of fantastic cases. This is Wikipedia. They've created, I believe, this tool is called Snuggle. It's a Flask application. Sorry, bottle. Apologies. And what they've done is, in their command line flags, they've added the option to be able to run a profiling job. And they, to actually call it from within Python code, you give it a string which is then executed, and you provide it the state. So it's just throwing in all the state there from the rest of the module, and the output file, which is this named temporary file. It'll then, the only thing that they seem to sort of care about is the cumulative time, and they only want the top 10 functions. This is a tiny little GUI application that was written for the One Laptop Per Child, also the Sugar Labs project. It talks about kids and hunger and development issues. And so what they do is they just import the main program around the main application. So I'm starting to gather some evidence here that in the real world, my intuition about staying at the integration test level, not worrying about the whole application, I'm sort of losing the battle, as it were. And here's another application that I sort of plucked out of nowhere. You call the main function and then write it to a hard-coded location every time. So this means that we have no ability to go and compare today's results with next month's results. This KDE cross thing is sort of a plugin. Not plugin's going to be definitely the wrong word. It will enable, I believe, Ruby, Python, and JavaScript to be scripting languages within wider KDE projects. And I assume this is testing the ability to convert Python integers into sort of C unsigned integers, this thing. Just a guess, I'm not quite sure how it works. And likewise with string compatibility. And you just call this runner thing. The reason why I've got this up here is not that it's indicative or representative of good code. It's just it looks like it's pretty unmaintained, and they didn't really get very far. So it's kind of the relief of being not the only one having problems with this is kind of good. And again, so this is a tiny little GUI application. All they're doing is running the main function, and they're not saving the state, so they can't maintain it over time. Canonical this is what they do to profile their Django application. They will remove the ability for Gargoyle, which helps out with testing Django apps, I believe. And they'll isolate every test by setting the timeout to 0, so there's no caching. And then they use that class which discovers tests. They'll run everything again through unit test, but again, and they're returning. This is interesting, actually. This result here, which is a string being passed into profile, is actually being sucked out afterwards through locals. And again, they are using the whole application, and that it doesn't look like I just think that what we'll get, no one's storing their results over time, and they're not profiling components. So there is code speed. Everyone's been to speed.pypy.org. That thing is open source, and you can run it today. You need to go with the grain slightly, because they are thinking about language implementations, but the language is there. And you can run nose with the profiler for the unit test layer. And I saw this was relatively common in Stack Overflow. You run from the shell, the CPython, send everything to output, but you run nose as a subcommand, which, fair enough, right? If it works, it works. But that struck me as interesting. But I'm not sure if I can add much to the discussion. So this is a question for you, really. I mean, should projects have like a profiling directory? Can I suck out using Python's introspectant? Well, date's easy to get. Can I get where I'm profiling? And maybe, could I look inside the directory where the module is and kind of use heuristics to determine, am I a Git repository? And if I am, can I pull out the current SHA so that I can also save all of that state in a file, which I can then compare over time to previous and future results. So luckily, we started a little bit late because we've had a relatively short talk. This is sort of the end. I'm genuinely curious if anyone in the audience has had and what their experiences are and how they integrate profiling with the rest of their workflow, because I'm sure that the rest of the group, the rest of us would be really interested in figuring this out. If you do have any thoughts, please do come down to the mics.
Hi, I have some thoughts, and I'm going to try and turn them into a question, but it's kind of a little bit still ill-formed. There are lots of stories about profiling, but most often connected with optimization, which comes as the next step, such as the person who spent all their time finding which was the worst piece of their code, and they spent all this time optimizing it until somebody said, look, do you realize you've just optimized the idle loop? That is the loop that's executing when nothing else is happening. And then there are situations where your code's performance is so dependent on the data it's given. I'm thinking, various sorting algorithms have bad cases, for instance. Sure. So really, I guess I'm wondering whether it's not possible that people will use profiling when they have otherwise well-functioning code, which for some set of inputs or on some situation has suddenly blown up in their faces, and they go, oh no, what's happening? I don't understand this. I need something to help me do it, to understand it. And it's not something they're going to be deploying or using all the time.
So one way to think about that as a question would be to say, like, when can you justify taking half a day to sit down and run these profilers over your code, given that it is Python and that you kind of know that it's going to be somewhat slower than the other alternatives anyway? And wouldn't it be best to spend that day on the next feature, right? So if you're not in a capacity, just come down. Feel free. You're not interrupting. We're right at the end. It's more discussion time. I don't have a good answer apart from the fact that in my side projects, it's interesting. But again, I wouldn't want to spend my own money if I was paying me as a developer to find things that are interesting. I'd really rather serve my customers.
If I can just have a follow-up question.
Sure.
When you started looking into this, did you have any idea on what something you might find out that would satisfy you? Yes, here's something really important that I've discovered about profiling. Well,
I think the line profiler and the memory profiler are really, really useful tools because they provide you very specific and very actionable outcomes. So one of the problems with the with the standard profiling machinery is that it only provides you granularity up to the function level, and at least if you can think about using those other two tools in a way that works within your workflow for everybody else, then you've got the chance to be able to actually make a change to your code that's relatively cheap and in terms of your own time, and hopefully is very cheap in terms of the cost of running your code. So on the clock, I have another 7 minutes to go, but I'm really happy to sort of wrap up there if people are keen to. I don't know if we're ready to get on with the close, and hopefully we can get out 5 minutes early for tea. Thanks so much, everyone.